Okay, this is our second example of a two-step mole conversion. Again, it's two steps because we're going through the conversion process twice. So, I'm going to go ahead and write my conversion factors again. We've got the molar mass, which is measured in grams, is equal to 1 mole of a substance. We have 22.4 liters of a gas is equal to 1 mole of a substance, and we have 6.022 times 10 to the 23rd atoms or molecules or formula units, otherwise known as particles, is equal to 1 mole. So this problem says we have 6.39 times 10 to the 25th molecules of CO2, and we want to know how many liters of CO2 it will make. Well, I look at my conversion factors, and I'm going to start with molecules, and I don't have one that goes from molecules straight to liters. I go from molecules to moles, and then moles to liters. So we write down the number we start with, 6.39 times 10 to the 25th molecules of CO2. I don't abbreviate molecules because that gets confusing with the mole sometimes, so I just write out the word molecules so that we don't get confused. So 6.39 times 10 to the 25th molecules of CO2. I do my little railroad track. And since I have molecules of CO2 on the top, I need it to cancel out. So I'm going to write molecules of CO2 on the bottom. And if I'm converting from molecules to moles, I'm going to put moles of CO2 on the top. Now we look at our conversion factors to figure out the numbers. The number in front of mole is 1. The number in front of molecules is 6.022 times 10 to the 23rd. So you look at your conversion factors. Whatever number is in front of it, that's what number you write there. This means our molecules will cancel, and we'll be left with moles of CO2. But I want liters, so I keep going. And again, if I have moles of CO2 here, I want it to cancel, so I'm going to write moles of CO2 here. And I want liters, so I'm going to write liters of CO2 on the top. And 1 mole, so 1 mole is equal to 22.4 liters, so 22.4 liters. Alright, moles of CO2 cancel, moles of CO2 cancel. I'm left with liters of CO2, which is what the question asked for, so I now plug it into my calculator. Multiply across the top, 6.39 times 10 to the 25th times 1 times 22.4, and then divide by the bottom. So I do 6.39 times 10 to the 25th times 1 times 22.4 equals that number. And then I divide it by Avogadro's number, 6.022 times 10 to the 23rd, and I get 2,377 liters of CO2. And there you go. Oh, sorry, this should be 2,380 because I have 3 significant figures. So I need to have 3 significant figures. That is correct. Alright.